Hello, everyone. Very happy to be here. Welcome to this live stream webinar brought to you by CreateDB. And today I'm very excited to welcome one of our customers, TGW Logistics. TGW Logistics is a global leader in warehouse automation and intralogistics. And I have with us today Stefan Stricker, Head of AI at TGW Logistics. Welcome, Stefan.
Hi, welcome. Glad to be here.
So today we are going to go into the operations at a warehouse. Your data holds a lot of information. It's good to collect the data, but it's even better, if you start to leverage this data to better operate and get, better and more reliable operations. So we will show you today with Stefan how you can leverage your data to reduce downtime, streamline maintenance, and empower your teams with instant access to the knowledge they need. So thank you, Stefan, for joining us. And I will hand over to you to introduce us to TGW and all the great projects you are doing there.
Okay, thank you, Stefan. So TGW is a warehouse automation company, meaning we are building distribution centers. And me and my team, we are data-driven, and we're implementing machine learning, AI, and data use cases for our customers, but also internally. And today I'll speak about one use case using machine learning, where we create a digital service for our customers to smoothly operate the warehouse, but also I'll discuss an internal use case where we leverage large language model for internal use case and customer support. So in this image, you see what, no, go back to this image. In this image, you see what TGW is actually doing. We are a company with 4,500 employees. And this is what we built for customers like Amazon, Zalando, or grocery companies like Coop. And these distribution centers are the reason why you get your order you placed online the next day if it runs smoothly. If it doesn't run smoothly, you might have to wait another day or two in order to get your delivery. So how does such a distribution center work? On the upper right side, you see the storage and shuttle engines. So there are all the goods placed. And these warehouses are huge, so you can have a couple of 100,000 different items in such storage systems. And when you place an order, a shuttle goes to the storage, puts the carton with the items in it on the conveyor system, and the conveyor system brings it to the pick center. And on the pick center, you have the pickers. They put the items you ordered in the target tote, and then it gets sent to departure. And such a distribution center can handle, on a busy day, it can handle up to 100,000 items per day, and the pick center can handle up between 600 and 1,000 items picked per hour. So it's complex, it's huge, and this is why we need some digital assistance in order to operate such a warehouse. And the impressive capabilities of these fulfillment centers rest on three foundational pillars, namely automation, digitalization, and data-driven decision-making. And this is why in our internal development, we focus on three main topics as process monitoring, data-driven maintenance, and expert systems. Expert systems are important because due to the large amount of automation, the people working at the warehouse need to have more and more different skills, because more automation means you need less people, but still, if something breaks or if you have to deal with a problem, you have to know many different topics, and this is where we support the warehouse operators with expert systems. Data-driven maintenance is the topic where you want to predict or prioritize maintenance tasks in order to reduce downtime. And the process monitoring is the topic where you want to know, how is my warehouse running? Is everything on time? Is it running on full speed? Is the performance good enough? And if it's not good enough, to act accordingly. So what is process monitoring in our case, and the use case I'll discuss today? It's data-driven and AI-based supervision of logistic processes, meaning we monitor the warehouse constantly and we monitor the operations. We want to identify anomalies and notify the operator when actions are needed, and we recommend actions on how to solve the problem. As an example, let me guide you through anomaly detection. So there are different reasons why the performance of a pick center is not good enough. And the performance is one of the key performance indicators of such a distribution center. It means, for example, how many items are picked per hour, because we need a certain amount of items picked in order to fulfill all outgoing orders. And it could be that, so on there you see a pick center, there's a left side and the right side. On the left-hand side, there's always the source. On the right is the target. For example, you order socks and gloves, for example. So you have your target node. It's there. The source node arrives with the socks. You take the socks, put it in the target node, press a button, the source node leaves. The next node with the gloves comes. You take them, put it in the target node, and then also the target node leaves because the order is fulfilled. Now, the performance could be influenced because there is no source target coming, or there is no target node coming where you can put the items in. Could also be that there's a slow picker or an unplanned picker break, and there are also other kind of reasons. For example, not enough inventory, the totes with the inventory are already at another pick station, and so on. Okay, so maybe go back to the slide. So what we did in that case, go back to the previous slide, please.
Yeah.
So what we did in that case is we created an anomaly detection. First, knowing when the picking performance is not good enough, and then with the anomaly detection, we did some tagging with a classification, what's the root cause of the slow picking performance. And the root causes, some of them are listed here. And what we did in practice was that before such warehouses are built, there's huge simulations running. And we took simulation data to train our model. And after the model, which was trained on the simulation data, we went to the real warehouses and refined the models. And now this is running in production. Another issue for a digital assistant is that all the orders need to be at the departure, at the trucks and so on, at a certain time. And we monitor all order lines and the shipment times. And together with the picking performance and our prediction on how the picking performance will be in the future, also based on the different order profiles, we can recommend and tell if all the shipments are made in time. And if not, we can make suggestions and recommendations to either close or open pick centers such that all shipments are reached in time. And I also briefly want to discuss a second use case, which is not for warehouse operations, but rather is an internal use case. So TGW, we built the warehouses, so we build the mechatronics, we build the software, and we also provide lifetime services, which includes maintenance and remote support. As you can imagine, in the remote support, it's not like we a telecom provider where you usually get asked the same questions. There are a lot of different topics coming in from mechatronics, wiring, software, and so on. And it's really hard to put that in some kind of knowledge base or a chatbot with basically follows some kind of decision trees, because each warehouse has some customization and the problems do not appear that often. And there's always some portion or percentage of unique problems that never showed up, but there might have been some similar problems. And this is why we started building an AI-powered ticket assistant, which now supports our remote services. So let me start with the problem description. And the challenge in our remote services that there can be a long review time, meaning that also tickets coming in could be in the wrong language. So you need, first of all, a translation of the tickets. That could be if there is an handover in remote support levels. So if the first level support cannot resolve the ticket, it goes to the second level or to the third level. And then usually for us, third level only speak German, but the ticket could be in Italian. So we need translation. If we have this level handover or an handover over shifts and a ticket has been very long, then for the new remote service agent who gets the ticket, it takes a very long time to understand the ticket history and what actually was tried and what's going on. Another problem is that in remote service, we have a high employee fluctuations. So it makes it hard to maintain high quality and fast resolution times, and also leads to long onboarding. And of course, every ticket is solved differently because humans are different. And another feature is that the billing reports differ in quality based on who writes the summary, what was done to resolve the ticket. The solution for us is a digital assistant powered by AI that on the one hand can summarize support tickets. It provides translations in arbitrary languages, and it acts as a knowledge base. Plus, it also suggests solution based on similar historical tickets. How does it work in practice? So you open a ticket or a ticket is assigned to you. You can open the ticket history. The agent summarizes the ticket and translates it in the language you want it. It displays similar past tickets. What we did on that is that we analyzed 170,000 historical tickets with large language models. And in order to find similar past tickets, what we did, with the LLM, we created question-answer pairs of similar ticket. So the context of the task, the LLM got extract the relevant question and problem and extract the solution. So we extracted a lot of question-answer pairs and stored it into GradeDB, which we then retrieve through similarity search, and the agent can then, and we suggest solutions based on the most similar tickets, what was done in the past. And this is how it works. It's now integrated in our ticket system, We also, if a ticket is closed, we automatically generate a summary, and this is then sent to the customer. So here you see how it works. We have the question on the right-hand side that was extracted by the LLM, and we later retrieve and the answers, and we have some other metadata which might be important in order to provide the most relevant tickets to the remote service agent. Exactly, and it's basically then a lookup of the relevant FAQs based on the vector embeddings. So the key features and the benefits are the summarization. It provides concise summaries of the service tickets and saves the agent time. It makes the translation automatically. It suggests solutions. Of course, through all this process, you have a lot of time saving. It increases the productivity and also improves the customer experience through faster resolution time. And an additional topic, which is not listed here, is for onboarding. You could also type in your own questions and get tickets from the past and the resolution, so you can browse through a lot of incidents that happens and get yourself get a faster onboarding. How do we, or I think, this whole topic will evolve into the future? So you have seen 2 digital assistants. We are working on more. At the moment, each assistant has its own model, and you have to go to a certain digital assistant to solve a problem. I think in the future, through the APIs and the MCP protocol, it should be possible, if a problem appears, the agents can navigate through the different digital assistants, retrieve some information, and then decide which is the best solution or which assistant is actually the correct one to trigger. And that's it.
Great. Yeah. That's great, Stefan. Thank you very much for the walkthrough. So process monitoring, one thing, anomaly detection, second aspect, and these knowledge assistants also, where you leverage the vector embeddings. So very thorough usage of everything you can do around automation and AI. So to get into further down into the architecture, and so Stefan mentioned they're using CreateDB as a database to help with those different projects. So let me explain a little bit deeper, what we do with CreateDB. So CreateDB, first of all, is a distributed SQL database, which means it can easily scale by adding more nodes. So it's an easy horizontal scaling. And it's designed for real-time access to fast-moving data. So imagine a world where you want to get real-time insights into data being produced. So you don't have to wait for minutes and hours to get the data available. It's a matter of a second, sometimes milliseconds, to get the data in and being able to analyze it. And the beauty is that it doesn't depend on the structure of your data, and also it's not impacted by the volume of the data. So it can easily scale, and in terms of data formats, it accepts multiple types of data. It can be time series data, typical to what you can collect through sensor data. It can be text. You can collect text from the different documents. So we mentioned the FAQs we collect from the different tickets. So it's typically some text documents. You can also collect from different aspects if you're having some geospatial data. That's also something you can easily store. Tabular data as well, coming from your different systems like CRMs and ERPs and so on. And also you have many tools that sending you JSON data, JSON payloads. So that's also something you see in the sensor data. So you can combine all of that together into the same storage. And from there, you can make very easy queries and aggregations. So you can aggregate across any type of field. It can be a field that is already into a specific field of your into a specific column of the table, but it can also be a field that is nested down into a JSON object. You can also make some ad hoc queries, which means aggregation is fine. So when you make analytics, when you have dashboard, it's great to have good aggregations and powerful aggregations. For that, we're leveraging columnar storage. Also, making added queries is very useful. For example, if you want to inspect what's going on, I'll say, oh, okay, I got a dashboard telling me something is maybe needs some kind of inspection. I can create my own queries and get instant insights into specific information without having to change the database schema or implement new indexes. You can also make some search with CreateDB, which makes it a very interesting search engine. You can do full text search, but you can also do geospatial search and vector search. So by combining those different types of search, you have a large possibility of use cases where you can make both search directly into the text, but also search for similar patterns with semantic search. And as AI is requiring more and more data to access in real time, we are feeding AI models and AI frameworks with real-time data. And that's something we are going to get into more details. In terms of consumption of this data, so everything is done with native SQL, which makes it very flexible. And it can be consumed by analytics or BI tools for your dashboard and for analytics. But it can also be consumed by specific applications. So assuming you want to give your employees a specific app, or you want to expose to your partners or to end consumer specific apps that need to access data in real time, that's something you can connect to CreateDB easily with the drivers. And you can also connect to specific platforms to make some data inference and so on. So if we look at some key capabilities, so I mentioned the different data types. So CreateDB is multimodal. You manage all those different types of data. And minimizing the time between data ingestion and data query is very important. So you ingest the data, it's automatically being indexed and is automatically available for query. And the query speed also is very important, which means that you can have the whole cycle in a matter of seconds, sometimes milliseconds, depending on the data you ingest. So it's extremely fast compared to batch pipelines. So here we are moving towards real-time data pipeline. Also, in terms of maintenance flexibility, it has an auto-indexing capability, which means you can enable that all the fields, even the ones nested into JSON objects, are all automatically indexed by default, which means that if you are changing your queries over time, if you are planning for some specific aggregations, but then there are some business needs that force you to inspect your data in a different way, you don't need to go through a specific maintenance. The data is already available, is immediately available for aggregations and query thanks to auto-indexing. And that's also very powerful when you make some ad hoc query. Because if you want to expect at some point you want to make some specific joins that are not being planned necessarily upfront, and it's still possible with CreateDB because all those fields are automatically indexed. Also, imagine you have sensor data where actually the data is evolving over time. You have a new sensor, and this sensor actually it's a new version, and he adds a new column to the data he sends you. So you don't need to update your schema. You can decide that you want to have specific fields that are flexible. And if there is new data coming in, the schema can automatically adjust. So that's also something very powerful. In terms of architecture, it's cloud native. I will explore that in more detail in the next slide. It's distributed, and also it's highly available with automatic repair. And it leverages simplicity of SQL, which makes it very easy for developers to consume the data. So in terms of architecture, it's shared nothing architecture, which means you can add more nodes as you go. So as the volume grows, you're adding more nodes to your cluster. And every node is equal, which means you don't have any master slave. Every node is equal, and it can accept queries and ingestion. And if a single node fails, the other ones will build a quorum, and they will make sure that the cluster keeps working with a high availability. In terms of deployment, it can be deployed pretty much everywhere. So we have CreateDB as a service. If you go to CreateDB Cloud, to our website, you can easily sign up and get access to your cluster. But you can also deploy it yourself, either on-premise or on your own cloud. And it can also be deployed, as we saw earlier, also directly in the factory. So you can deploy that at the edge and make sure it can connect and synchronize with your central IT. So in terms of time series data, there are some interesting functions being available so that it facilitates the exploration and analysis, analytics on this data. So you can easily extract the time, you can make some time bucketing, you can manipulate window functions to look at specific time periods, and you can make also some statistical aggregates and advanced filtering and logic. So everything you want to analyze on your time series data is out of the box, so you don't have to come up with complex language or complex syntax to get it done. So all those feature functions make it very easy to do whatever you want to do in terms of time series manipulation. You also embed some interesting concepts such as partitioning. So if you have tons of data, you can decide to partition by month or by week or even by day sometimes. And you can decide which type of storage is being used for each partition. And then also when you make your queries, the cluster optimize access to the different partitions to make sure you get the maximal speed in terms of data retrieval. So here there are some examples on the SQL language. So for the ones familiar with this language, I mean, you see it's very easy to read. You can also implement some commentable expressions to facilitate your query. You can also make some subqueries. You can make some joins. When it comes to accessing the JSON data, it's a bracket notation, so you can select your JSON field and then access a specific property within the JSON object. So it's very flexible in terms of data access. So now, let's talk a bit about what you can do with machine learning and AI with CreateDB. So there are different patterns we have identified across the different projects. So first of all, if you want to do machine learning with CreateDB, you can use CreateDB as a feature store, where actually you get real-time access to your data, and you can easily aggregate and get the data you need to train your models. Then you can, so once your models are trained, you can use CreateDB for real-time inference. So where you get access to the metrics in real time to make sure your models are working fast and get you the results you need in real time. And all the prediction also you're making with some predictive analysis, you can be also stored into CreateDB for further analysis. When it comes to vector embeddings, you can use CreateDB as part of a RAG pipeline, where actually you decide to store into CreateDB different vectors that you generate through an LLM. And then when people are asking through a chatbot, for example, similar to what we saw earlier, if they're asking a specific question, then an embedding is being automatically created by the LLM. And then thanks to similarity search, you can easily retrieve from CreateDB the similar vector embeddings, the ones that are closest to your request. And then all those closest neighbors, so we call that the closest neighbors, are being fed back or sent back to the LLM to generate a response. So that's a powerful implementation also of CreateDB as a vector store. And the last type of project we're seeing more and more is implementing CreateDB as part of a global orchestration system. So if you want to go with agentic AI, you're creating different types of agents. Each agent has a specific function, a specific specialty. And if you want to orchestrate them together, you can definitely leverage CreateDB as a central store or as a database to get the data you need and being interacted through the MCP server. That's something we implemented recently. So now CreateDB is MCP enabled, and any LLMs can automatically interact with CreateDB thanks to this feature. So these are the different patterns we've seen over the past month in managing AI projects. And so that I think we covered most of it today. As you can see, all those different implementations can really turn into business value, similar to what Stefan presented earlier. And Stefan, before wrapping up, are there any recommendations you would like to make to our audience on things they should be careful with, or things that the lessons you learn over the years, by managing those different projects?
Well, especially with machine learning and AI use cases, um, don't think, also think about the business case and the users, and try to solve the problems as simple as possible.
Start small and grow. That's your
Yes.
message. Yeah. Yeah. So fail fast and iterate fast.
Yeah, and also the important thing is the data. Sometimes you need machine learning, but also try traditional methods.
That's good. That's good lesson learned. Thank you. So I hope you found this webinar helpful. The recording it will be available on our LinkedIn page and also on our YouTube channel. Once again, Stefan, thank you very much for showing us the different interesting projects you are working on at TGW Logistics. It's a very exciting project, delivering very high value. And so, if people want to know more about TGW, what would you recommend?
Visit our website. There's also a lot of different YouTube videos where you can see our distribution centers in action.
Great. Thank you, Stefan. Thank you, everyone. Have a great end of your day. See you soon. Bye-bye.
Thank you. Bye.